Now, at around 60%, we can clearly see the difference here. I equally love this one. Hey, I'm not a knight, but I love this one. It's only about 3 to 5 images. I still love it though, but it's kind of too corporate for me. We can see that this one actually does look a lot like Dylan. I love this one. I don't play the guitar, but hey, I love this output. It really does look like me. Hello there, my gorgeous friends on the internet. Welcome back to another video. So today we're going to be talking about text to image generation, and specifically we're going to be looking into FLUX Dev, which is a text to image model provided to us by Black Forest Labs. And essentially in this video, what we're going to be doing is we're going to be creating a LoRA adapter for FLUX Dev, a LoRA adapter that's simply going to plug into FLUX Dev, the model itself, which is the base model itself, and generate consistent, realistic photos of someone or, something or a product or whatsoever thing you want to create. Now, specifically what this model does is it is this really amazing model that creates, guys, this model is insane. It's really, really cool. This model is probably, if not the best open source model I've seen out there in generating realistic and consistent text to images. This model is simply astonishing. And we have a couple of people actually using this model in their businesses, deploying models which can essentially generate images of maybe people setting up pipelines and stuff like that. So in this video, we're going to be creating this LoRA adapter, which is essentially fine-tuning and generating images based on the dataset. And the goal here is to essentially create realistic and consistent images of a person, as the images we can see here. So we can see me here in various scenarios. Here, I really love this one. I love the aesthetic look here. It was kind of, the vibe here is kind of like I guess I'm like an actor or something like that. And this one, I love this one. I don't play the guitar, but hey, I love this output. It really does look like me. I guess it kind of messed up a little bit with the fingers here. The fingers kind of gives it out here, but overall, it's a slightly decent image, I would say. I equally love this one. Hey, I'm not a knight, but I love this one. Maybe my face is not exactly the same. It's not exactly what is here, but hey, you get the idea. And here, this is my best generation. This is exactly me, exactly how I would smile. This is really, really amazing. Now, this one is a little bit corporate. I still love it though, but it's kind of too corporate for me. But I love the energy here. And this was one of my best generations as well. I'm just holding a cup of coffee and a cafe, and I'm just chilling. Essentially, what we are going to be doing in this video, as I mentioned earlier, is we're going to be using this foundation model by Black Forest. This model, by the way, which is a 12 billion parameters model, we're going to be using this foundation model and essentially creating an adapter which we're just going to be able to plug into this model, and it would be able to generate realistic and consistent images of a person. In this case, if you have photos of you would like to generate, or you would like to see yourself in a certain style or something like that, you would definitely use this methodology. So I'm going to be showing you exactly how you can do something similar to what I just showed you. So our goal here is to create a LoRA model that will sit on top of the FLUX foundation model. And essentially, LoRA stands for low rank adaptation, and it's a parameter efficient fine-tuning methodology that actually adds additional weight to different parts of the base model, which is in our case FLUX 1 dev model. And in our case, we're only going to be training those weights that we're going to be adding. Now, this is very efficient because we don't have to essentially train the entire model. And at the end of the day, this is only going to be like a small file which we're just going to be plugging into the base foundation flux model, and it's going to give us our output. Now, we're going to see a little bit of this more in action when we actually train our adapter and actually load that adapter and, merge the weights with the base model, the foundation model, and eventually generate our image in the style that we'd want. And it's, again, going to be keeping the consistency in the images depending on obviously our dataset. Now, a lot of this is thanks to this very interesting repository which I found. It's called AI-toolkit. This is a very, very, very interesting repository I found. And essentially, this repository, what it do here is they provide us ways to actually train Flux, the Flux 1 dev model. And I would definitely recommend this here if you want to train your LoRA adapter. Now, I have actually created a notebook for this. So the notebook which was created from that repository, I created a notebook here because I actually changed a little bit of, some few parameters, like the LoRA and stuff like that. So a couple of parameters which I changed. Now, most of these things are going to be in this notebook, which I'm going to share in the description of this video. And now we have another notebook, which is the Inference notebook, where we're going to be essentially loading the base model and merging it with our adapters, which we have fine-tuned, and at the end of the day generating our image, as we can see here. And I would like to actually mention that this notebook actually is from the AI-toolkit repository. And essentially what I did is I just copied the repository over to, I created a new repository because obviously I did some, modifications, not modifications, but I did some little tweaks in terms of parameters and everything in between. And so before actually heading into the notebook and running it, I actually wanted to talk a little bit about the actual methodology that a lot of people are starting to use when training the Flux model. And most of what I've seen is heavily inspired from the Dream Boot method. The Dream Boot method from Google Research. And essentially what is happening here is they're able to take a limited amount of input images, as low as 5 or 10, and then using a unique token combination or some sort of trigger phrase per se, train this model with these prompt combinations with this limited amount of photos and the trigger phrase, of course, during the training. And essentially what that would do is would be able to essentially hyperfixate on activating all of the training neurons when that trigger phrase actually comes up. In Google's example here, they use the unique identifier and trigger phrase V here. So when they get the fine tuning with only about 3 to 5 images of the dog, along with prompt combinations using the unique identifier within it, as they ran inference on that training model, if you put the V bracket here into the prompt, it was most likely to actually, route the generation to those trained parameters and then actually pick up on some of the generalizations of what it was trained on. And so much of actually the training model that I've seen follows a lot of this methodology. And the AI toolkit that we'll be using is not an exception. So we're actually going to be able to, generate a lot of these good examples that I showed here using only 10 photos. And I'm saying 10 photos here because 10 for me is like, 10 is acceptable. I've seen people using, 5 or something like that, but I think 10 to 20 is going to be a good, a good number. Now, we're going to move straight forward to setting up the dataset. And for this video, we're going to be using the images of a friend of mine called Dylan. is a very good friend of mine in the industry, an amazing guy. And I would actually really love to thank him for letting me use his images for this tutorial. Now, here we have 10 images of Dylan in this folder. We have 10 different images of Dylan, different posture, smiling, serious face, smiling as well, and everything in between. Now, notice how I renamed the images with photo one, in a sort of chronological order, Now, this is very important because if we look at the training, if we come here in the training here, now I'm going to explain this later, but let's go step by step, yeah? So if we look at the training here, we are actually going to be needing to, in the um, notebook here, they mention that we actually need to provide the names have to match, the prompts. So we need to have a file called with a specific name, and then the file has to be a txt file with the same name as the image, and this is very important. And for this, for now, they support GPG, JPEG, and PNG. So your images have to be in any of these three formats. Now, so for us to now create the prompts, because we already have the images, for us to now create the prompts, we're going to paste this prompt here into ChatGPT because obviously we want to go faster for this video. And I'm going to put this prompt down in the description below so you can just, copy it and paste it into ChatGPT. We're going to paste this prompt here, and then we're just going to copy all these images, and then we're going to upload it into ChatGPT. And essentially, it's gonna upload the images, and then it's gonna, basically what this prompt does is I said I provide you some photos, put this in this order and in this specific, it should be photo2.txt. Inside the file, you should describe the images, sort of provide a caption of the images, and we need a trigger, which is what we were mentioning when we're talking about Dreamboat here, Google's research, which you have our trigger year V. We see here in this prompt here, it says a dog in the beach. So it uses the input images, sort of you pass in the trigger, the unique identifier, and then it sort of uses its knowledge of the base model to sort of, from your prompts with your trigger phrase, it generates the image. Now, we have uploaded the images. We're just going to hit enter here and wait for it to, process or request. Guys, while this processes this request, I just want to let you know that I really appreciate you for watching our videos. Thank you for hanging around to this point of the video. If you enjoyed the video, please smash that subscribe button, hit the like button, press the notification bell, and drop down a comment below if you have any questions or anything in between. Now it has created what we needed. We're just going to click here and download it. So now that we have already done everything, we're just going to hit inside what it has done, and we're just going to check everything, make sure everything is okay. The first image with a bright smile. Okay, so everything seems to be good. So the trigger word, essentially this trigger word is going to be replaced while we are going to be training the model. We're going to add the trigger word. We're going to see that in the notebook. Now that everything seems good, what we're going to do is we're just going to copy this, or we're just going to carry it, and we're going to take it to the parent folder. And then since this one is empty, we're just going to delete this. So now we can see we have the name of the image is the same as the name of the txt file. So if we open this, we can see here he's smiling with the teeth wide open, of course. We can see in the prompt here, it said with a bright smile, showcasing confidence in a floral, shirt, relaxed setting and all of that. Of course, probably this data set is not the best because, it's just him with, the same dress. Obviously, it would be better if we had him maybe with different clothings, or like green, yellow, or something like that. But essentially, this is basically what we are trying to do. Now that we have everything here, we're going to head straight forward to the notebook. Heading back to our notebook here, we can just immediately start running the cells. So we're going to install this. Before we install this, we're going to connect, of course. And by the way, guys, for this to be able to work, you might want to purchase some, GPU units for Google Colab. I actually tried this with CPU or the TPU. I'm not sure. I tried this and it didn't work. I'm not quite sure why. But then I just went ahead and purchased some A100 GPU. Now, once we have that, so once we've run the first cell, we run the second cell, and essentially here in this second cell, we're just basically cloning the repo into our workspace. So I'm going to open here so you can see what's going on. So this is the folder. It's basically downloading the code from GitHub. So we downloaded that, and then we sort of cd and git update all the sub modules and everything in between, installing the requirements as well, as we can see here. So this is going to be running. I'm just going to fast forward the video. Now, while this actually installs, I might want to go ahead and essentially start explaining what the code actually does. Now here, pretty much, we're just basically prompting to get our HuggingFace token, HF token, access token, and your HuggingFace token. What you want to do is you want to get your HuggingFace token on HuggingFace. So you go to your HuggingFace account, you go to your profile, you go to settings, and then you click on access token. So once you click here, you just basically get a new access token you can create a new access token, or you can basically use an existing one by just simply regenerating, invalidate and refresh your access token. So what I'm gonna do is I'm just gonna invalidate and refresh this one. I'm gonna copy this. By the way, guys, I'm gonna revoke this access token, so don't even bother trying to use it. Of course, you can just create yours. Come on, guys. So I'm gonna go back to a notebook, and once this is done, so this is run successfully, we're gonna enter our access token. So we copy the access token, we're gonna paste it here and hit enter. So it's gonna set the environment variable here, and then we're gonna run this next cell here. And after that is done, now we have our setup. And basically in our setup here, it's pretty simple and straightforward. So pretty much here, our setup here is our configuration, and basically it's pretty well documented if you ask me. And normally this would be in a YAML file. However, since this is Google Colab, we have to have that this way. And basically, if you run it with the default, which you get from the default repository, so if you come here, I guess that should be in training, if I'm not mistaken. Examples, that should be in examples. So these ones actually are the YAML configurations. So if you come here, for example, here's the YAML configuration. All of those configurations we have inside our notebook, we have them in our YAML here. And in this case here, you would mostly use this if you're deploying this, or if you're running this not on Google Colab. Of course, you're running this on a system, you have everything just there for you to just run the commands. But for our case here, we're gonna be modifying a few of the variables here. And the first thing we're gonna modify here is our name. So basically, we're gonna use the name of my friend for this, Dylan. So we're gonna use his name, Dylan Flux LoRA V1, and then here we have our process, and the process here we have our training output. So this is the root folder to save the training sessions, the samples and weights and everything in between. So at the end of the day, this is what we're actually going to be pushing to HuggingFace. That's everything that's going to be in this folder. Now we're using CUDA, and then here you remember, guys, I mentioned about the trigger word. So here's our trigger word. In this case here, we're going to have our trigger word is going to be Dylan. So I'm just going to copy this here, Dylan. So for the trigger word here, you can have anything, but as long as it is kind of unique that when you call that trigger word, so when that trigger word is called, then it sort of uses those adapters, so the trained adapters to generate according to that specific style or that specific way you want it when you actually train the model. And this again, like I'm saying, is we can see it here where we have AV, this is our trigger word, dog, and the beach. So if we run this, for example, with this prompt, the trigger word is Dylan, a Dylan dog in the beach, it's gonna try to make it a dog, kind of like a Dylan face and everything. Maybe we can try that after, but you get the idea. Now we're gonna head straight back to our notebook here. So we have our LoRA networks, LoRA here. Actually, here you can use 16, or you can use 8, 16, or 32. However, the higher you go, the more complex it is. So for this case, since we're dealing with images, and images are kind of like complex, complex things. I personally do think images are complex, in my opinion at least. So here in the original notebook it's 16, but I set it to 32 because I believe this is better for capturing something more complex as a face. Now those are for linear, that's for LoRA linear, LoRA alpha 3232, and here our precision here is float 16, and here we have the save every. So we're going this 250 here is okay. Save every of this many steps. So every 250 is gonna save a sort of precision. So max step saves to keep, we set it to 4. How many intermittent saves to keep? Now our data set here, we're gonna have our data set here. We haven't uploaded our data set yet, by the way, guys. So let's just finish explaining and then we're gonna upload our data set. So that's for the data set, and then we have the captions here. We get everything here. Captions dropout, we add dropouts for captions 5% of the time here, and we sort of shuffle here set to false, but essentially we can shuffle the captions and order them, essentially split them with commas, and this is pretty much to make it a little bit unpredictable. Yeah. Now resolution, we have for catch latent to disk. This is very hard to pronounce. Catch latence to disk, and then we have set to true. We have a resolution. Batch size 1 steps. We are going to run 2000 steps, which is the total number of steps, and essentially you want to keep this between 500 to 4000. This is kind of like a good range, but play around with it and see what you get. So we're going to leave this at 2000. Gradient accumulation steps 1, and then we have other configurations there. And note here we have our foundation model, which is the model by Black Forest Labs, the Flux 1 Dev, which is the base model which I mentioned here. So pretty much you just copy this link. It is already there, by the way, so you don't need to copy it and paste there, but that is what we have here. Is Flux true quantized, so we're running on 8 bits mixed precision here. We have other configurations here. We have our sample. Our sample here pretty much is, say, okay, sample every 200. So every 200 or every this many steps, we're going to generate a sample with these prompts. Okay, so we're going to use these prompts to generate a sample. And essentially, we're using the trigger word holds a sign that says, I love prompts. Right now, the trigger word here is going to be replaced by what we have above here, which is Dylan. So it's going to be like Dylan holding a sign that says this. And in our data set as well is the same thing. The trigger word is going to be swapped with the actual, the trigger in parentheses, in square parentheses, is going to be replaced by the actual trigger word. Now we have all of that, the seeds, walk seeds, gradient scale to 4, sample steps 20. We have everything set up. Now that we've set up everything, we can just go ahead and run this cell. And once we've run this cell, so that should run perfectly. And after running that, we can just hit forward to running the training job. So this is basically where the magic happens. And we want to check our folder. Oh, I totally forgot. We didn't add our dataset. We didn't upload the dataset. We need to upload our dataset here. So we're going to go back. We're going to highlight all of this. We're just going to carry it, and then we're going to upload it in here. So it says, okay, warning. Yeah, just say okay to that warning. By the way, that warning is just saying, okay, this is a temporary environment and everything you do here is not going to be safe or whatsoever thing. So upload our dataset here. So now that our dataset is uploaded, now we can run the job here. So we run the job and that should pretty much work. I almost forgot to add a dataset. I don't know why and how I almost forgot that. So after running the job, it's going to download the model and then it's going to run the training job. Now, after the training is done, we want to push it to HuggingFace, of course. So I might want to go to HuggingFace here. I'm going to go to HuggingFace here and I'm going to create a new model, right? And then what I'm going to do here is I'm going to name it. So I actually named it Dylan. So I'm going to copy this and come here and paste it here. Oops, I pasted so many times. So I'm going to have it like this. And then license, let's just say MIT license, public, yes. Now that we have this set up, I'm just going to copy this, come back to my notebook. That is the model name or the path to the model on HuggingFace. I'm just going to copy that. So while this is running, I'm just going to come here and I'm going to paste this here. And for this here, since we actually set it to Dylan here, so we're going to copy, this is what we're going to copy, and then we're going to come down here and we're going to paste it here. So that's just pretty much about it. Now that this is actually running, we're going to wait for it to train, and then we're going to come back after the training is done. So while this is running, since we did specify that we want to have some samples, we should run some sample prompts to actually sort of evaluate or sort of see how the model is actually learning inside our configuration up here. So if you come here, we're going to see all of this prompts, the sample prompts, and essentially it's going to be it's outputting actually the results of this prompt into our output directory. So while this is running here, let's just take a sneak peek at the result outputs for the sample prompts. This is generally very funny. So if we open our output here, we open to the name Dylan Flux LoRA V1 samples, we can see that it has actually generated the first sample. And let's take a sneak peek in it, shall we? So if we double click here, we're gonna see, okay, this is definitely not our friend. This is definitely not Dylan. Let's check the second one. Okay, this is not Dylan. Okay, again, guys, this is still the first. It's just at 2%. It's at 2%. Okay, let's not expect some Marvel something from it. So we're gonna see together how this progresses. Let's check this other one. Okay, this one is blur. Okay, this one is definitely not Dylan. Definitely not Dylan. Bear with me, guys. We're gonna see how this is actually learning, because this is actually very interesting. As we go forward, I am going to be showing the various samples. So we're pretty much at 40% now, and I would really like us to take a sneak peek at the generation samples. Now, let's try this one. Okay, this is definitely not Dylan. Try the second one. Okay, it's kind of... Okay, hear me out. It's kind of getting to it. Maybe the hairstyle is a little bit weird, but... Oh, we can see here it's still generating the samples, though. So let's just check a couple of them. This one kind of looks like a small Dylan kid. I mean, it doesn't look 100% like Dylan, but there is that a little bit of Dylan in it. I bet if he watches this video, he's gonna think it looks a little bit like him. Not 100% like when he was a kid. Let's check out this one. Okay, this is definitely not Dylan. This one definitely not Dylan. The person here, I can't really tell if the person here is white or black, but I mean, from the hands, definitely. I guess from the face, I would say the person is white, so the model is still getting there. It's definitely not it yet, I would say. We check another one here. It's loading. Why is it taking so much time to load? Okay, it was still loading, by the way. Let's see. Okay, this one kind of looks a little bit like Dylan. The face is kind of coming out, but the hair is definitely not it. The hair is definitely not Dylan. It's definitely not it. Okay, this one too kind of looks like low Dylan. His black, he's getting black. He's getting black is weird though. Why am I saying like that way? This one, I would say it's not Dylan. Now, at around 60%, we can clearly see the difference here. So, looking at this here, we can clearly see that it definitely looks like Dylan. And this other picture as well kind of looks like him. So, basically, the model is essentially learning well. Good. Now that we're done training, we can actually go through the sample prompts and see how well the model performed or how well the model was learning. And out of the box here, we can see that this one actually does look a lot like Dylan. I like this one. The hands are pretty neat. I like it. It looks good. Now I'm going to refresh this real quick and try to upload the other ones. So while that one is loading, I'm going to upload this other one. You see, if you paid attention at the beginning of the video, we had a more white person kind of musician here. But okay, this doesn't look 100% like Dylan, but it kind of looks a little bit like Dylan. Though not 100%, of course. Now, I'm not sure why the other ones are not opening. But while those are loading, we're going to try to push our model to HuggingFace so we can have everything actually save up there. Now, we're just going to run this cell, which pretty much what it does is it imports the upload folder from the HuggingFace hub library, and then it basically uploads the everything that is in the output LoRA FLUX LoRA v1 folder, which is this one here, everything that's in here. So it's gonna upload that to HuggingFace. So we're gonna wait for this to upload to HuggingFace. Now, while we wait, we might want to try to open again the samples here. Let me see. I opened the last one here. Okay, this one doesn't look like Dylan at all, especially the hairstyle. It doesn't look like Dylan. Oh, this one looks actually impressing. Really good. And we try this one. This one kind of looks like Dylan, if you ask me. I would say that it does look like him, actually. It does look like him. Let's check the other one. Okay, this one doesn't look good at all. So we see overall the model actually learned how Dylan's face looks like. Now we are saving the model weights and uploading that to HuggingFace, and it looks like it has already uploaded here. So if we come here, we refresh. Now we refresh here, we go to files, we can see that everything has been uploaded, and we can see it 2 minutes ago. Now what we're gonna do is we're gonna use this model in Inference, and pretty much what we're gonna be doing is we're gonna go to this notebook here, which is the Flux Inference with LoRA. Again, like I mentioned earlier, I'm gonna be dropping the link to this notebook down in the description below, so you might want to check that. So now we're going to install the dependencies here. We see that we already have installed the dependency. We need diffusers, transformers, accelerate, and the rest. So after installing that, there are two things we need to provide here. So we need to provide our HuggingFace token. So we're going to copy the token from HuggingFace. We're going to provide it here just to make sure that token is correct, or just to make sure that token is right. what I'm gonna do is that I'm gonna go back to my HuggingFace here. I'm gonna go to my account just to make sure everything is right regarding the token, because I might have generated a new token if you followed the the previous sections of the video. So what I'm gonna do is I'm gonna refresh. I'm gonna generate a new one right away. It's gonna give me a new one. I'm gonna copy it again. I'm gonna revoke this, so don't even waste your time to use this. So I'm gonna copy that. I'm gonna come in here and I'm gonna paste that, and I'm gonna run the cell. And before I run the cell, I need to provide so this one is already gonna be there, but I need to provide the model weights. That's the LoRA weights which I just trained. Now to do that, I need to go where I uploaded my model, which is the model I created of recent. I just copy this and then I come back to my Inference notebook and I paste it here. And then I need to provide, since there are many weights, many endpoints with checkpoints here, I need to provide this specific weight that I want to use. These other weights are, from previous checkpoints, which maybe this one was good. I would just copy the name and use this one instead. But in our case here, we're going to use the latest one. So we're just going to copy this, and then we're going to come here, and then we're going to paste it here. So after pasting this here, we can then run this cell. Okay. I'm going to try to disconnect this and run it again. Inference. I'm gonna terminate this, and then I'm gonna try to connect again to the GPU and reinstall the dependencies. So I'm gonna install the dependencies here. So once it finishes installing, it's gonna run the second one here. Now it's gonna download the base model, which is from the one from Black Forest Labs, the Flux 1 dev, and then it's gonna load the model where it's gonna create a pipeline and everything in between, and then we're gonna be able to use the pipeline to actually prompt the model. So we're gonna try something very similar to what we have. So we're gonna try Dylan as a medieval knight. Okay. Let me see if I have another name here. 30. The prompt here, everything is good. So we're gonna wait for a couple of minutes. Once the model is downloaded and the model weights are loaded to a pipeline, then we're gonna run the generation of the image. Now that the model has been downloaded and the model weights has been loaded onto a pipeline, we can pretty much just generate the image by clicking here, and here pretty much what you can do is you can just provide any prompt that you want or anything that you want to see that characters. And note that we are using the word Dylan, which is, if you remember when we're running our training, we used a trigger word called Dylan. So this is our trigger word that we specified when we were training our LoRA adapter. Of course, we specified Dylan, so we do have to use that Dylan for it to trigger those particular weights in our model. Now we're gonna wait for it to generate and see what it gives us. Okay, this is not the best. I would say this is not so good. Sometimes it is not so good the first time, and you have to generate a couple of them to actually see something which is kind of close to what you're looking for. But overall, you should know that the more data set you have, or the more dynamic samples you have of your character or what you're actually trying to fine-tune your LoRA adapter to generate, the more you have variations of that, the better your model is going to be, the better your output is going to be. So we're just going to generate that again and see what it gives us. Okay, this one definitely looks better than the previous generation, and that's pretty much about it. Thank you so much for watching this video. if you like this video, please consider subscribing to our YouTube channel, smash that like button and hit the notification bell so you won't miss interesting videos like this one. Thank you so much for watching the video again. Until the next one.